a descent into the darkness between galaxies, the void, vast and silent, where emptiness reigns. Yet within these deserts of space, faint and inexplicable structures emerge, spirals where no galaxies should exist, vast, city-like arrangements of light and matter suspended in regions once thought barren. They are not galaxies in the familiar sense, nor clusters in the patterns we know, but something stranger, spiral architectures hidden in the cosmic void. What built them? Chance, gravity, or a deeper law woven into the fabric of reality? The mystery unsettles, for the void was meant to be empty, and yet, within its depths, the cosmos seems to be writing structures beyond comprehension. The question hangs like a shadow: who or what assembles these spiral cities in the heart of nothingness, the void? For centuries it was imagined as absence, the emptiness between stars, the black canvas upon which galaxies shine. To early astronomers, the universe appeared as a scattered ocean of lights, stretching outward without clear pattern or structure. But as the tools of observation sharpened, the illusion of randomness began to dissolve. The first glimpses of the cosmic web in the 20th century, telescopes and spectroscopy revealed that galaxies were not sprinkled evenly through space. Instead, they formed clusters, groups bound together by gravity, strung along filaments like beads on invisible threads. Between these filaments lay immense gaps, regions so empty that for millions of light years there seemed to be nothing at all. These deserts of existence became known as cosmic voids. The discovery unsettled even as it inspired. The cosmos was not a simple scatter, but a vast cosmic web, filaments, walls, and knots of galaxies enclosing caverns of near-nothingness. Computer simulations based on dark matter and cosmic expansion confirmed the pattern structure emerging. From chaos, gravity weaving galaxies into an intricate tapestry. But within this tapestry, the voids stood out. They were thought to be sterile expanses, regions where the density of matter was too low to spark the birth of galaxies. Vast and silent, they were the cosmic deserts, the natural counterpoint to the bustling metropolises of galactic clusters. The architects of Snooze. Was in this era that astronomers like Vera Rubin reshaped our understanding of the hidden cosmos. Rubin's meticulous measurements of galactic rotation revealed that the visible stars were not enough to explain the gravitational pull binding galaxies together. An unseen scaffolding of dark matter was required, invisible halos of mass surrounding galaxies and perhaps threading across the entire universe. This revelation carried implications for the voids. If dark matter was the skeleton of cosmic structure, then even the emptiest regions might not be truly empty. They could carry faint scaffolds of invisible matter, too thin to host luminous galaxies but still shaping the geometry of space. The great sky surveys that followed, catalogues like the CFA Redshift Survey and later the Sloan Digital Sky Survey, mapped millions of galaxies in 3 dimensions. The results were breathtaking. Sheets and filaments forming walls around enormous voids, some stretching hundreds of millions of light years across. The universe, once thought boundless and uniform, was revealed as architecture on the grandest scale. The birth of void science as voids entered cosmology. They were treated as the null spaces of the cosmic web laboratories for studying emptiness. Models predicted them to be largely featureless, gently expanding faster than denser regions, with only the occasional faint dwarf galaxy wandering their depths. And yet, even in these deserts, something strange began to appear. In the maps of galaxies and the faint whispers of radio signals, Astronomers began to glimpse hints of alignment, arcs, and patterns where none should exist. At first, these were dismissed as statistical flukes, the human eye's tendency to find order in randomness. But as the data grew, the whispers grew louder. In certain void regions, galaxies seemed not scattered, but arranged, faint spirals, curling arcs, formations that echoed the geometry of galaxies themselves. The idea was absurd. Spirals are the work of dense environments, the gravitational choreography of stars in motion. To see them in voids, assembled from faint galaxies and hydrogen traces, was to glimpse order in the very heart of nothingness. The faint signals radio astronomy played a critical role. By tuning in to the 21-centimeter hydrogen line, astronomers could trace clouds of neutral hydrogen gas invisible to ordinary telescopes. To their surprise, in void regions, faint spiral-like structures emerged, curling across millions of light-years. These were not galaxies in the familiar sense, but vast arrangements of gas and faint stars aligned in arcs and curves at the same time. Redshift surveys revealed dwarf galaxies, small, fragile systems, arranged in unexpected patterns inside voids. They did not simply float in isolation. They appeared to form structures, as though following hidden tracks carved into the emptiness. These findings challenged the neat picture of voids as barren. Instead, voids whispered of hidden architectures, subtle structures strung across emptiness, delicate yet coherent. The first spiral hints in the late 20th and early 21st centuries. A handful of astronomers flagged the first unmistakable hints, faint spiral distributions of galaxies inside voids. The arcs were vast, city-like, curling into patterns eerily reminiscent of galactic spirals, but on scales millions of times greater. They became known, informally, as spiral cities, not galaxies themselves, but city-like assemblies of matter suspended inside voids. Unlike the bustling density of galactic clusters, these cities were ghostly, faint, stitched together from dwarfs and gas, arranged as though the void itself were shaping them. The term captured the paradox. Voids were supposed to be emptiness. Instead, they appeared to harbor spirals, not silence, but order, not absence, but hidden architecture. The early reaction, the astronomical community, responded cautiously. Some argued the spirals were illusions born of incomplete data. Others suggested they might be statistical chance, the random scatter of galaxies accidentally mimicking spiral order. But as surveys expanded, the patterns refused to disappear. The Sloan Digital Sky Survey mapped larger volumes of the cosmos, and once again, faint spiral arcs appeared in void regions. The whispers had become murmurs, and the murmurs, questions. What mechanism could build spirals in emptiness? Was dark matter weaving structures invisible to light? Were these fossils of turbulence from the early universe frozen into place? Or were they something more? Relics of physics not yet known, scars of events predating the cosmic web itself. The awakening of a mystery by the dawn of the 21st century. The existence of void spirals had become an open puzzle. They were not as bright or obvious as galaxies, but they were real enough to demand explanation. The void, once thought silent, had revealed its voice, a voice that spoke in spirals, in structures too coherent to be ignored. And so began the great inquiry into the spiral cities of the galactic void. A mystery that suggested emptiness is never truly empty, and that even in the vast silence between galaxies, the universe continues to write its patterns of order. The spiral hints inside the void were at first faint curiosities, but as data grew sharper, the implications began to take shape, and with them came unease. For what the surveys revealed was not just anomaly, but contradiction. The void was meant to be absence, the desert floor of the cosmos. Instead, it bore signs of order, as though something unseen had been building structures where no structure should be. The expectation of emptiness standard. Cosmology rests on the CDM model, lambda, cold, dark matter. In this framework, galaxies form in the dense knots of dark matter halos. Gravity pulls matter into these invisible wells, igniting stars and shaping galaxies. The voids, by contrast, are the cosmic deserts. In simulations, they are regions where matter thins to near nothingness, expanding more quickly than the rest of the cosmos. They should host only a sprinkling of faint dwarf galaxies, wandering without pattern, too fragile to form coherent structures. This expectation was comforting. The universe seemed divided into regions of chaos and regions of structure. The web belonged to the filaments. The voids belonged to emptiness. But the spiral cities blurred that line. The shock of spirals in nothingness, the first confirmed spirals inside voids, were not dense or luminous like the great spirals of Andromeda or the Milky Way. They were fragile, tenuous, assembled from faint dwarf galaxies and threads of hydrogen gas. Yet their geometry was undeniable. Arcs, curls, and rotations that mimicked the order of galactic spirals. This was shocking because spirals are the outcome of density and dynamics. Galactic spirals arise when disks of stars and gas rotate under gravity, forming arms through resonance. They require mass, rotation, and gravitational choreography. But the void has none of these in abundance. To see spirals emerge, there was like finding seashells in the driest desert. Order where chaos should reign. Geometry without the architect of density. Contradiction with CDM. The CDM model could not easily explain this. It predicted void galaxies, yes, but scattered, not aligned. Certainly not gathered into arcs, spanning millions of light years. For cosmologists, this meant one of two things. Either the observations were wrong, or the model was incomplete. Both options carried weight. If wrong, then the spirals were illusions born of chance, artifacts of incomplete surveys. If incomplete, then CDM, the bedrock of cosmology, might require revision. The shock deepened when simulations struggled to reproduce the patterns. Supercomputers could generate cosmic webs with vast voids, but the void galaxies in those simulations rarely formed coherent spirals. The models predicted emptiness. The data hinted at architecture. Echoes of galactic order scientists could not ignore the uncanny resemblance. The void spirals were not identical to galactic spirals, but the echo was strong. Just as galaxies form arms through resonant waves of density, could void galaxies be caught in larger scale resonances, ripples, of gravity across emptiness, sculpting them into arcs? If so, then voids were not passive deserts, but active environments shaped by subtle physics. The void itself was not silence, but resonance, carrying memory of forces unseen. The question of dark matter became the first suspect. If voids were not empty, but threaded with faint filaments of dark matter to diffuse to glow, then perhaps these hidden structures guided galaxies into spirals. The galaxies would be like lanterns strung along invisible wires, tracing the unseen scaffolding of the void. But this explanation carried its own shock. If dark matter filaments were that organized in voids, then dark matter was not simply the passive glue of galaxies. It was an active architect, shaping spirals in the very places thought barren. The role of dark matter would have to be reimagined, not just scaffolding for clusters, but weaver of hidden architectures in cosmic deserts, resonances in the void others. Speculated about gravitational resonances, vast low-frequency oscillations of matter and space-time rippling through voids. Just as a vibrating string can form standing waves, perhaps the fabric of voids carried slow spirals, freezing galaxies into arcs over billions of years. If true, then the voids were not silent expanses, but resonant chambers humming with the hidden music of the universe. The fear of pattern-seeking skeptics warned of caution. The human eye is a pattern-finding machine, evolved to see order even where none exists. Could the spiral cities be illusions, the statistical clustering of galaxies misinterpreted as coherent arcs? Yet the more data arrived, the less convincing this skepticism became. Statistical flukes vanish under scrutiny. The void spirals remained, growing sharper with each survey. The emotional shock beyond the technical challenge lay a deeper emotional shock. The void had long been a symbol of silence, of nothingness. To find spirals, there was to find order in absence, a haunting suggestion that even emptiness could not escape structure. For cosmology, it was a challenge to theory. For philosophy, it was a challenge to meaning. If even nothingness births spirals, then perhaps the universe is compelled toward pattern, an architect not of chance, but of inevitability. The divide among scientists, the community, split in response. Some urged restraint. The spirals were anomalies, explainable within CDM once data improved. Others leaned into the paradox. If the model could not explain them, then perhaps new physics was at work. The divide mirrored past shocks, the discovery of cosmic acceleration, the mystery of dark matter, the bending of starlight by gravity. Each time, anomalies had reshaped physics. Could the spiral cities be the next revolution? The birth of a mystery, what began as faint whispers had become a storm. Spirals where no spirals should exist. Architectures inside deserts. Cities in the void. The shock was not simply scientific. It was existential. For if even the void carries spirals, then perhaps emptiness itself is an illusion. Perhaps the universe, at every scale, resists chaos. Perhaps order is not rare, but inevitable, even in the deepest silence of space. And with that realization, the mystery deepened. For the spiral cities of the galactic void were no longer curiosities. They were challenges, pressing against the limits of cosmology, demanding explanation. The shock of spirals in the void could not remain as rumor. Science demands evidence, refinement, persistence. And so the search intensified. If spiral architectures truly haunted the emptiness, they would have to reveal themselves under sharper instruments, broader surveys, and deeper analysis. What followed was a campaign across decades, telescopes sweeping the skies, satellites listening in silence, supercomputers recreating the cosmos in digital form. The Sloan Digital Sky Survey and the cartography of voids, the late 1990s, marked the rise of one of astronomy's most ambitious projects, the Sloan Digital Sky Survey (SDS). From a telescope in New Mexico, Sloan mapped the positions and redshifts of millions of galaxies, building a three-dimensional atlas of the universe. When the maps were unveiled, they astonished even seasoned astronomers. Galaxies traced vast filaments, threads, connecting clusters across hundreds of millions of light-years. And between these threads gaped the void's immense cavities, seemingly hollow, but Sloan's resolution was enough to see more than emptiness. Within some voids, faint galaxies appeared to cluster in arcs. In places, their distribution hinted at curling structures, suggestive of spirals. These were not illusions of a single patch of sky. They repeated across multiple voids, faint but consistent. The spiral cities were no longer whispers. They were cartographic features in the largest map of the cosmos ever made. The Dark Energy Survey and fainter. Lights. The Dark Energy Survey Day, beginning in 2013, probed deeper. Using a 570 megapixel camera mounted on a telescope in Chile, it captured the faintest galaxies, some 100 times dimmer than those seen by Sloan. Day confirmed that voids were not truly empty. Dwarf galaxies lurked there, fragile, diffuse, barely holding themselves together. Yet their arrangement was not random. In several void regions, the dwarfs aligned in arcs, like pearls on faint threads. Spirals once again emerged, subtle but undeniable. More intriguingly, Day revealed hints that these structures extended far beyond visible galaxies. Gravitational lensing, the bending of background light by mass, suggested that invisible scaffolds of dark matter traced the same arcs. The spiral cities, it seemed, were not merely alignments of galaxies. They were expressions of deeper structures carved into the void by dark matter itself. Hubble's deep fields and the whisper of alignment. The Hubble Space Telescope, though narrow in its view, offered extraordinary depth. Its deep field images revealed galaxies, so faint and distant that their light began its journey when the universe was young. When pointed into void regions, Hubble found not emptiness, but galaxies of astonishing fragility. Ultra-diffuse galaxies with so few stars. They resembled ghostly smudges. Some carried spiral arms, despite their isolation. Others appeared aligned, as though responding to hidden currents. The void was no longer silent. Even here, galaxies whispered of order. The James Webb Telescope and hydrogen spirals. With the launch of the James Webb Space Telescope, JWST, in 2021, the investigation entered a new era. Webb's infrared eyes could see the coldest structures, faint gas, ancient stars, the scaffolding of the invisible dot in the depths of certain voids. Webb observed hydrogen clouds, traced in curling arcs, as though the gas itself was being organized into spiral forms. These were not luminous spirals of stars, but primordial spirals of matter itself, faint signatures of architecture on scales beyond comprehension. Webb also found surprisingly mature galaxies in void regions, their disks and structures fully developed far earlier than theory predicted. These rogue spirals, floating in cosmic deserts, seemed to defy the logic of environment. How could galaxies so coherent evolve in the most barren regions of space? The supercomputer universes. While telescopes revealed the sky, supercomputers recreated it. Simulations like the Millennium Simulation and Illustris sought to model the growth of structure from the Big Bang to the present. Billions of particles, representing dark matter and gas, danced under the laws of physics, weaving cosmic webs. Across virtual universes, the simulations reproduced the filaments and voids with astonishing accuracy, but the spirals inside voids remained elusive. In some runs, faint arcs appeared, born of subtle resonances or turbulence in the flow of matter. Yet rarely did they mimic the clarity of the observed spirals. This gap between simulation and observation deepened the mystery. If the spiral cities were real, then something was missing from the models. Perhaps dark matter behaved differently than assumed. Perhaps unknown forces or fields shaped the voids. Or perhaps the initial conditions of the universe carried imprints, still unfolding as spirals today. The role of hydrogen and radio astronomy parallel to optical surveys. Radio astronomers turned their instruments to the voids. By tuning to the 21 centimeter line of hydrogen, they mapped neutral gas invisible to light. To their surprise, hydrogen clouds in voids were not evenly scattered. They often curled into arcs, some resembling fragments of spirals. These gaseous forms suggested that the spiral cities were not illusions of galaxies, but deeper patterns imprinted in matter itself. Future instruments, like the Square Kilometer Array, SCAR, promised to map hydrogen across cosmic scales with unprecedented precision. If spiral architectures lace the voids, SKA may draw them in detail, revealing their true scope. The alignment problems, the data grew, a new puzzle emerged, alignment across scale. Some spiral void structures appeared to orient themselves in the same direction, even across distances of hundreds of millions of light years. This defied expectation. Voids should evolve independently, shaped only by local conditions, yet the spiral arcs seemed to whisper of coherence across the cosmos, as though guided by an unseen hand spanning unimaginable scales. If confirmed, such alignments would demand new physics correlations stretching across voids in defiance of randomness, suggesting hidden connections woven into space-time itself. The deeper layers of the mystery. By the mid-21st century, the spiral cities of the galactic void had become one of cosmology's strangest frontiers. No longer ignoble, no longer explainable as flukes, they pressed against the boundaries of theory. Were they artifacts of dark matter, filaments too faint to simulate, resonances frozen into voids by primordial turbulence, echoes of conditions before the Big Bang, or evidence of exotic physics, hints that the universe carried symmetries beyond our comprehension? Each observation deepened the paradox. The void, meant to be silence, was instead architecture. Spirals rose in emptiness, fragile yet coherent. Ghostly cities in deserts of space, the uneasy realization for cosmologists. The deeper investigation brought both progress and unease. The data were undeniable. The spirals were real. The challenge lay in explanation, and so the community faced a choice. Either the spiral cities were accidents of perception, coincidences that would dissolve under even sharper scrutiny, or they were truths, signs of hidden architecture that demanded new physics. Neither answer was comfortable, yet the void itself had spoken, and in its spirals, the universe revealed that even its emptiest regions were not free of order. At first, the spiral hints inside voids seemed fragile, almost deniable. They could be flukes of data, artifacts of incomplete mapping, or the human eye chasing patterns where none existed. But as the surveys grew sharper, the spirals did not vanish. They grew, they multiplied, and in their scale and coherence, they revealed something that could no longer be ignored. The void was not empty. It was alive with hidden order. The rise of the rogue spirals, perhaps the most startling discovery, was the rogue spiral galaxies. These were not faint dwarf smudges loosely aligned into arcs, but fully formed spiral galaxies, grand design spirals with arms unfurled in sweeping grace, floating deep inside voids by every expectation. Such galaxies should not exist there. Spirals require density, interaction, accretion of gas. In the fertile regions of filaments and clusters, they thrive. In the barren desert of voids, they should wither if they form at all. Yet Webb and Hubble revealed them, lonely spirals, magnificent and inexplicable, shining as if sculpted in defiance of their isolation. Their very existence raised questions. How could they gather enough gas in such emptiness? How could they form coherent arms without the gravitational tides of neighbors? These rogue spirals were not just anomalies, they were contradictions. Cities in deserts, order blooming in silence. The coherence across vast scales of stranger was the alignment problem. As galaxy catalogues expanded, researchers began to notice that certain void spirals and arcs seemed to orient themselves in similar directions, across distances spanning hundreds of millions of light years. This was not supposed to be possible. Voids are too large, too causally disconnected for such coherence. Their galaxies should evolve in isolation, their orientations random. Yet here were structures whispering of order that stretched across expanses too vast for communication. It was as though the void spirals were not separate phenomena, but fragments of a larger pattern, pieces of an architecture stretching beyond our comprehension. The crisis of lambda CDMEACH discovery strained the CDM model further. The cosmic web, as predicted by simulations, allowed for filaments, clusters and voids, yes, but not spiral coherence in emptiness. To reconcile the data, cosmologists proposed hidden dark matter filaments threading voids, faint enough to elude most detection but strong enough to guide galaxies into spirals. Others suggested primordial turbulence from the early universe, frozen into the void and slowly unfurling across billions of years. Yet the models faltered. No simulation, no matter how detailed, produced spirals as coherent and grand as those observed. The void refused to conform. It carried secrets beyond the equations. Hints of cosmic rotation. Then came the most unsettling hint of all. Cosmic rotation. Studies of galaxy alignments across both filaments and voids began to suggest large-scale spin, as though sections of the universe carried a preferred direction of rotation. This contradicted the cosmological principle, the assumption that the universe is isotropic, the same in every direction on large scales. If void spirals were aligned by such rotation, then the voids were not silent caverns, but vortices in the fabric of spacetime. The universe itself might twist, its emptiness shaped into spirals by currents older than galaxies. Einstein's relativity allows for such rotation in principle, though no evidence had ever been found on cosmic scales. If confirmed, it would be a revolution, reshaping cosmology from its foundations. The philosophical paradox. The escalation was not only scientific but philosophical. Voids had long symbolized absence, silence, nothingness. To find spirals there was to find architecture in emptiness, a contradiction to the very idea of the void. If even nothingness blooms with spirals, then perhaps the universe carries an inherent tendency toward order, not chaos punctuated by islands of structure, but structure pervading even its emptiest reaches. The spiral cities became symbols of this paradox: silence that sings, emptiness that organizes, voids that are not void. The question of origins. If the spiral cities could not be explained by standard models, then where did they come from? Were they products of hidden dark matter currents, fossils of turbulence seeded before the Big Bang, or imprints of exotic physics, modifications to gravity, new particles or dimensions unseen? Some began to whisper of pre-Big Bang relics, echoes of universes before our own whose patterns survived in voids. Others wondered if the spirals were signatures of intelligence on scales beyond imagining, cosmic engineering not of planets or stars, but of voids themselves. Such speculation was fringe, but the mystery encouraged it. For the spiral cities of the galactic void were too coherent to ignore, and too inexplicable to contain within the boundaries of known science. The deepening divides the data grew. So did the divide among scientists. Some clung to CDM, confident that improved simulations and hidden filaments of dark matter would one day resolve the spirals. Others pressed for new physics, pointing to the alignments, the rogue spirals. The cosmic rotation hints as evidence of a deeper truth. The debate grew sharper, echoing past crises in cosmology, the discovery of cosmic acceleration, the insistence on dark matter, the very acceptance of the Big Bang. Each anomaly had once been resisted, then embraced. Would the spiral voids follow the same path? The escalation, complete by the 2020s and 2030s, the spiral cities were no longer curiosities. They had become a frontier. Astronomers mapped them with increasing precision, physicists struggled to simulate them, philosophers meditated on their meaning. The void, once thought barren, had revealed itself as architect. Spirals rose in its silence, coherent across scales. Defying chance, defying expectation, the mystery had deepened to its limit. Either the spiral cities were illusions, or they were truths that demanded a rewriting of cosmology. And if they were truths, then emptiness itself was not empty. The void was alive with hidden order, a revelation that threatened to unravel our most trusted models of the cosmos. The spiral cities of the galactic void had outgrown denial. They persisted in maps, in radio signals, in the faint whispers of galaxies and hydrogen traced against emptiness. To explain them, science had to reach beyond the familiar into the realm where mathematics meets imagination. What followed was not certainty, but speculation, reasoned, daring, often controversial. Each theory attempted to answer the same haunting question: what builds spirals in the heart of nothingness? Dark matter filaments. The most conservative explanation pointed to dark matter. If the voids are not truly empty, but threaded with ultra-faint filaments of dark matter, then perhaps the spiral cities trace these hidden strands. In this view, galaxies are like lanterns hung along invisible wires, their alignments reflecting the unseen scaffolding. The faint hydrogen spirals could be gas-funneled along these filaments, twisted by gravity into curling arcs. But for this to work, dark matter must be more than scaffolding. It must be capable of forming delicate, coherent patterns in regions of extreme emptiness. Simulations struggle to reproduce such order, hinting that our understanding of dark matter, its interactions, its behavior at large scales, may be incomplete. Cosmic vortices. Others proposed that the voids themselves might rotate. If sections of spacetime carry vast, slow vortices, they could twist galaxies and gas into spirals. Einstein's general relativity allows for such rotation in principle, though no evidence has ever been seen on these scales. Yet hints of cosmic alignment, galaxies and void spirals pointing in the same directions, suggest that something like rotation may be at work. If true, then the voids are not passive caverns, but cosmic whirlpools, spiraling under the unseen currents of spacetime. Primordial turbulence. Another possibility lies not in the voids themselves, but in the early universe. In the first fractions of a second, before matter settled into the cosmic web, turbulence may have rippled across space-time. Most of these flows would have dissipated, but in the vast emptiness of voids, they may have frozen into place, slowly guiding matter into spirals across billions of years. The spiral cities would then be fossils of ancient turbulence, imprints from a time when the universe itself was fluid and chaotic. This idea links the present to the beginning, suggesting that void spirals are not anomalies, but ancient memories, written into emptiness. Exotic physics. Some explanations venture beyond the familiar. Perhaps gravity does not behave as Einstein described on cosmic scales. Modified gravity theories, like MOND or emergent gravity, propose that unseen effects emerge in regions of low density, precisely where void spirals are found. Alternatively, unknown particles or fields could be at work. Interactions between dark matter and dark energy might generate coherent flows. New forces, hidden in the void, could align galaxies across scales. If so, then the spiral cities are not mistakes of observation, but signals of new physics waiting to be uncovered. Cyclic imprints. More radical still are the theories that look beyond the Big Bang itself. If the universe is cyclic, collapsing and rebounding across eternal ages, then relics of past universes may survive in the voids. Spirals could be such imprints, patterns seeded by a cosmos before our own, carried across the transition into this one. Roger Penrose's conformal cyclic cosmology even predicts such echoes. He argues that imprints from prior eons may appear in the cosmic microwave background. Could the spiral cities of voids be similar relics, fossils of universes older than time? If so, then the void spirals are not just anomalies, they are messages carried across cosmic death and rebirth. The shadow of intelligence and the fringe lies the most unsettling speculation of all: intelligence on cosmic scales. Some have wondered cautiously, controversially, whether the spiral cities could be signatures of design. If a civilization spanned galaxies, its engineering might not build planets or stars, but structures in voids, patterns vast enough to endure cosmic time. Spirals, chosen for their elegance and stability, could be written into emptiness as messages or monuments. Most scientists reject this idea, favoring natural explanations. Yet the thought lingers, fueled by the sheer scale and coherence of the spirals. If nature built them, it implies new physics. If intelligence did, it implies a cosmos far stranger and more inhabited than we imagine. The common thread, despite their differences, all these theories share one truth: the spiral cities cannot be ignored. Whether dark matter, vortices of space-time, fossils of turbulence, echoes of older universes, or something more, they demand explanation. Each possibility stretches science. Each suggests that the void is not silence, but song, not absence, but architecture. The philosophical weight of speculation is not weakness. It is the willingness to follow data where it leads, even into mystery. And here, the data leads into unsettling territory. The void, once thought barren, reveals spirals. The universe, once thought simple, reveals hidden order. If dark matter builds spirals in emptiness, then matter unseen shapes reality more deeply than imagined. If cosmic vortices twist galaxies, then space-time itself is restless. If turbulence froze into spirals, then the void is a memory of creation. If cyclic universes leave imprints, then time is endless. And if intelligence is at play, then the cosmos is a canvas far vaster than humanity ever dreamed. In every case, the spiral cities are revelations. They show that emptiness is never empty. They remind us that silence is never silent. They whisper that the universe is deeper, stranger, more ordered than cosmology has yet dared to admit. The spiral cities of the galactic void hovered between anomaly and revelation. To decide their fate, science turned to its instruments, the telescopes that see across light years, the satellites that map the relic glow of creation, the detectors that listen to space-time itself. For only through relentless observation could humanity hope to distinguish illusion from truth, noise from architecture, coincidence from cosmic law. Eyes on the darkness, optical and infrared telescopes. The Hubble Space Telescope had already shown the voids were not sterile. It captured faint galaxies scattered through emptiness, some carrying fragile spiral arms despite their isolation. But Hubble's vision, limited to the optical, could not pierce the faintest veils of gas and dust. With the launch of the James Webb Space Telescope, JWST, in 2021, the voids opened further. Its infrared mirrors revealed hydrogen clouds curled in arcs, dwarf galaxies lined along invisible threads, and rogue spirals glowing far earlier in cosmic history than expected. Webb hinted that voids were not deserts, but gardens of delicate, hidden structures. Looking ahead, the Nancy Grace Roman Space Telescope, with its vast field of view, promises to map these faint galaxies across immense volumes. Where Webb sees detail, Roman will see scale, capturing the architecture of voids in wide swaths of sky and on Earth. The Vera C. Rubin Observatory readies its legacy survey of space and time, a decade-long project that will image the entire southern sky. Every few nights, Rubin will reveal how void galaxies evolve, whether their spirals persist, and if alignments across voids truly exist. Mapping the invisible radio astronomy and hydrogen surveys, stars reveal only part of the story. Gas tells the rest. Radio, astronomers trace neutral hydrogen through its faint 21-centimeter emission line. This allows them to map matter even in regions where starlight fails. Already, hydrogen surveys have uncovered arcs and spirals in voids, whispering of structures larger than any galaxy. But the next generation of instruments will see deeper. The Square Kilometer Array, SKA, now under construction, will be the most powerful radio telescope ever built. With its vast collecting area spread across continents, SKA will map hydrogen across billions of light years, reaching into the voids with unprecedented clarity. If spiral architectures are real, SKA will draw them in exquisite detail, tracing the hidden filaments of gas that may underlie the spiral cities. The weight of the invisible, gravitational lensing where light fails. Gravity speaks, even in emptiness. Mars bends the path of background galaxies. By measuring these distortions, weak gravitational lensing, astronomers can map the invisible distribution of dark matter in void regions. Lensing studies already hint at faint scaffolds aligning with galaxy arcs. Future missions like Euclid, launched by the European Space Agency, are designed to map lensing across vast scales, testing whether the spiral void structures are shaped by hidden dark matter filaments. If Euclid confirms spirals in the lensing, maps mass itself curling into arcs, then the spiral cities will no longer be deniable. They will be etched not only in light, but in gravity itself. Listening to the fabric, gravitational waves, another frontier lies in gravitational wave astronomy. While LIGO and Virgo have detected waves from black hole mergers, theorists predict a faint background of ripples from the early universe. If voids carry hidden vortices or cosmic rotation, they might leave imprints in this background. Future observatories, like LISA, the Laser Interferometer Space Antenna, planned for the 2030s, could be sensitive enough to detect these whispers, subtle hints that space-time itself spirals in the void, simulating the cosmos. Supercomputers. As observatories parallel to telescopes, supercomputers act as laboratories for the universe. Simulations like a lustrous and eagle model billions of particles of dark matter and gas, evolving them under the laws of physics across cosmic time. So far, simulations reproduce the cosmic web with breathtaking accuracy, yet they struggle with the spiral voids. The arcs they produce are faint, incomplete, rarely as coherent as those observed. This gap is itself data. It suggests that something is missing from our models, a property of dark matter, a behavior of gravity, or an imprint from the early universe not yet accounted for. Each failed simulation is not failure but a clue, a shadow pointing to what remains unseen. The debate of illusion versus reality. As instruments grow sharper, the debate continues. Are the spiral cities real structures, or are they illusions? Born of human pattern-seeking, statistical analyses test the probability of chance alignments, comparing real maps with randomized simulations. The results are provocative. The spirals appear more often and more coherently than chance would allow. And yet, science demands caution. Only with the full sweep of Rubin, Euclid, Roman, Webb, and Scar will the truth emerge. Only then will the spirals be confirmed as genuine architectures or dissolved as statistical mirages. The long patience of science, this testing will take decades. The spiral cities are not a mystery solved in a single observation, but a riddle that requires generations of watching. Just as cosmic acceleration was revealed by decades of supernova surveys, and black holes confirmed through years of gravitational lensing, the spiral voids will yield only to long patience, but science thrives on patience. The voids are eternal by human standards. Their spirals will wait. And humanity, restless though it is, has already shown itself willing to spend lifetimes chasing faint signals in the dark. The edge of revelation as the tools converge. Optical telescopes, infrared eyes, radio arrays, gravitational wave observatories, and supercomputer simulations, the spiral cities stand at the edge of revelation. They are either illusions soon to be erased, or they are real, and if real, they will demand a rewriting of cosmic law. In the coming decades, humanity will know. The void itself will answer, and when it does, the silence of emptiness will either return or transform into the voice of spirals, a song written across the deserts of the universe. The spiral cities of the galactic void remain unproven, unresolved, unsettled. Perhaps future surveys will erase them as illusions of chance. Perhaps sharper eyes will confirm them as truth, revealing hidden architectures in the very heart of emptiness. Yet even now, before certainty, they hold power. For what they suggest is not only scientific, but philosophical, that even silence may contain song, that even voids may resist being void. The meaning of structure in emptiness, the void, was once the final symbol of absence. It was the canvas of space itself, the background against which all else was drawn. To imagine it as sterile was comforting. The universe had its architecture in the web of galaxies, and beyond that web there was nothing, but the spiral cities whisper otherwise. They suggest that absence is never absolute, that even emptiness carries potential, seeds of order waiting to unfold. If spirals bloom in voids, then the universe is not divided neatly between fullness and nothingness. It is structure all the way down, order layered even where we least expect it. This realization shifts the way humanity imagines the cosmos. The void is no longer dead space. It is a hidden garden, a place where laws of physics with delicate architectures invisible to the naked eye. The fragility of human understanding for centuries. Cosmology has been built on confidence. Newton's clockwork, heavens, Einstein's curved space-time, the CDM model of dark matter and dark energy. Each has expanded human vision, and each has eventually been revised. The spiral voids remind us that knowledge is provisional, a scaffolding always vulnerable to collapse. What if the spiral cities are real? Then CDM is incomplete. Dark matter is more mysterious than imagined. Gravity itself may twist in ways never measured. The story of cosmic structure would need rewriting. And what if the spirals are illusions? Then humanity is reminded of its fallibility, its hunger to find order in randomness. Yet even then, the search is not wasted. For in reaching into the void, in testing silence with patience, humanity proves itself willing to chase truth into the deepest darkness. The human place in the spiral there is also something profoundly humbling in this pursuit. On a pale planet orbiting an ordinary star, a fragile species looks into voids hundreds of millions of light years wide, searching for spirals faint beyond imagining. Why should such a search matter? Because it reflects what humanity is. To be human is to refuse silence, to listen even when nothing should be heard. The spiral cities are not only cosmic structures, they are mirrors of the human mind, a mind compelled to ask even when answers seem beyond reach. The symbol of the spiral has always carried weight. It appears in shells, in storms, in galaxies, in DNA. It is the pattern of growth and unfolding, the geometry of motion and memory. To find spirals in voids is to find this symbol written at the largest scale, echoing across emptiness. What does it mean that the spiral repeats from the smallest cell to the largest void? Perhaps it means nothing, an accident of mathematics. Or perhaps it means that the universe favors certain forms, that order arises not from chance but from law, repeating itself at every scale. In this sense, the spiral cities are not anomalies. They are inevitabilities, the cosmos insisting on its patterns even in its deserts. The question of nothingness at the heart of the spiral cities lies a deeper question. Can there ever be nothing? If even voids bloom with structure, then perhaps nothingness is an illusion. Emptiness is never empty. Silence is never silent. The universe cannot resist making order, even in its darkest caverns. This thought reshapes philosophy. If nothingness cannot exist, then existence is not fragile but inevitable. The universe does not fade into absence. It folds into deeper forms of order, patterns invisible until revealed, the echo of eternity, and yet the spirals also raise the spectre of eternity. If structures can form in voids, independent of galaxies, then perhaps the universe carries memory longer than stars, longer than light. The spiral cities may be fossils of ancient turbulence, imprints of universes before our own, or echoes of forces not yet known. In this way, they are not only architectures but relics. They hold the possibility that the universe is older, deeper, and more layered than humanity imagines. The final meditation, perhaps the ultimate lesson of the spiral voids, is this: that the universe resists emptiness, that even where we expect silence, there is song, that even in deserts there are cities, whether natural or engineered, real or illusory. The spiral cities remind us that the cosmos is stranger than its models, larger than its equations, more creative than its predictions. They reveal a universe that refuses to be barren, a reality that blooms even in absence. And for humanity, fragile and fleeting, there is beauty in this. To live in such a universe is to live in a story that is never simple, never closed. A story where even nothingness carries patterns, where even voids are alive. The spiral cities of the galactic void may or may not endure as scientific fact, but as symbols, they already endure. They remind us that the deepest silence is not silent, that the darkest emptiness is not empty, and that the cosmos, in every corner, insists on being more than we expect. They are mysteries in deserts, cities, in silence, spirals in the void, and in their haunting presence lies a truth both scientific and poetic, that the universe, even at its emptiest, is never truly empty at all.